So I'm back, and we're going to do a little bit of a different setup this week. I think I wanted to have a bit more of a detailed look at some of the technology. So instead of going through a whole bunch of them all at once, we're going to do something where I just kind of do a deep dive into one particular technology from one particular university, and I'll still have it randomly selected by random AI. And in this case, this week they came up with the University of South Florida. So in looking through their technological profile, I found something that I thought was interesting, which is a way of removing nitrogen from wastewater in a much more effective way than is currently done. So why is it important to remove nitrogen from wastewater? First off, there's a fancy word called eutrophication. I think I'm saying that right. I can't exactly pronounce it well, but it is the process by which too many nutrients, mainly nitrogen and phosphorus, are in water supplies, and they cause things like algal blooms and that cause massive die-off of fish and other marine and aquatic life. Mainly this is coming from things like runoff of fertilizers from farmland. So I live in Ohio, and one of the things that you'll notice if you live here is if you're anywhere near Lake Erie, a lot of times they will shut down various beaches from massive algal blooms for some reason or another. And most of the time, those massive algal blooms are caused by eutrophication, or the runoff of phosphorus and nitrogen. So phosphorus, they're both used in fertilizers. Phosphorus isn't really dealt with this particular technology, but nitrogen is. And one of the main types of nitrogen that is in water is ammonia. So it's commonly used in fertilizers. It's where the runoff comes from. And it's one of the primary things that wastewater treatment plants have to deal with whenever they're removing chemicals from the water. To do this, typically, they use a thing called BNR, which I think is called biological nutrient removal, according to the notes I have over there. But basically what this does is uses a type of bacteria that eats the nitrogen and it emits it as nitrogen gas, which is, 70 something percent of the atmosphere. The problem with that is that, it works well. It's been working well for a long time. The problem is that bacteria that does this requires oxygen. So it's a aerobic process rather than an anaerobic one. And giving oxygen to microbes that live in water requires a process called aeration, which is basically you throw oxygen bubbles into the bioreactor where these bacteria are trying to remove the nitrogen from the ammonia. That's expensive. Putting oxygen bubbles into the reactor costs something like 60% of a wastewater treatment plant's energy budget, which in itself is like 60% of the total operating budget of the wastewater treatment plant. So if you're able to eliminate the need for aeration in the nitrogen affixing and removing process, it's a massive cost savings for wastewater treatment plants. That is exactly what the University of South Florida's technology does. So basically they use a upgraded process that uses a type of anaerobic bacteria, which I think they call Anammox, I think is how you would say that in the lingo of wastewater treatment. And the process has been around since like the 80s, but it has a lot of limitations specifically around the bacteria themselves. So they're really finicky. They die off at slight changes in pH or become much less effective if the water temperature is slightly out of range of where they like it to be. And they get outcompeted by a lot of the aerobic bacteria. Especially in certain environments. So what the University of South Florida researchers came up with was a way of four-stage process. They came up with a four-stage process that first removes a lot of the organic carbon that is available in the water itself. So they use a process called, the process that the guys at the University of South Florida came up with was called partial nitrification / Anammox, or PNA, I guess is how you would say that. The process itself has 4 different steps. The first one is a pre-screening process called chemically enhanced primary treatment. Basically, it removes carbon sources from the wastewater that goes into the bioreactor that's removing the nitrogen. The second process uses a type of what's called a zeolite, basically a crystal structure that in this case is chabazite. Chabazite is how you would say that. It's a naturally occurring crystal in volcanic rock, and it's very, very good at doing things like ion exchange. So it allows positive, in this case, ions to pass through it and traps them inside of the crystal structure. Basically, it's a way of isolating ammonia by allowing it to get trapped in these crystals. The third process comes in eventually when the chapazite zeolites are saturated with ammonia, so they can't take anymore. There's a side stream, or what they call an AD side stream, that actually floods the entire reactor with very high ammonium concentration that suppresses a lot of the bacterial growth of the aerobic and other types of bacteria that can theoretically outcompete the anammox bacteria. And then at the same time, the chapazite zeolites are forced to get rid of their ammonia, basically allow it to release into the reactor. And at that point, they allow the actual PN/A process to go through. So the anaerobic bacteria, that is the anammox, the key constituent, then does their thing on nitrogen without the need for oxygen, essentially eliminating a huge part of the necessary cost of operating a wastewater treatment plant. And they can effectively do the same nitrogen removal as what would be required with an aerobic process, but without the massive energy investment. It has some other advantages too. So I think they said it decreased the overall need for the necessity of aeration by like 80% in their reactor. They also said that it decreased by 80% the amount of sludge that is created as part of the reaction. So that's, good. You don't have to get rid of that. And also it has the added advantage of not requiring additional organic carbon to be added. To be honest, it didn't really seem like that much of a deal. From what research I could tell, they use minimal amounts of organic carbon anyway, and it's a relatively inexpensive material. But it's nice to not have to do another chemical additive in a wastewater treatment plant, I'm sure. So overall, it has some major advantages over the existing setup. However, it is still relatively early on in the process of developing this. From what I can tell, the main effort was done through a master's thesis that was published on a benchtop scale demonstration of this, where it got these significantly good results with the total nitrogen removal. But scaling things into industrial wastewater plants is a tricky business. It would probably cost tens of millions of dollars and really require a significant amount of stepwise efforts to get this thing fully adopted anywhere. However, it has the advantage of being environmentally friendly in a number of ways, right? You have less sludge, you have less energy use, and you have less nitrogen in the water. So ultimately, there are people that want to support those kind of initiatives, and this technology from the University of South Florida fits really, really well right into that category. So if you're interested in learning more about this, you can reach out to their technology transfer office directly. They don't seem to have a technology manager specifically for this one. I think they just have a general technology transfer office. But I think that's it for this week. So if you're interested in learning more, as I said, go reach out to USF's tech transfer office. But if you're interested in learning more about general technologies that are available from universities and research labs here in the US, they just need a little bit of a push through to get them off the ground and into the commercial market. This is the place where every week we take a look at a new technology. So thanks for your time, and I hope you guys enjoy your week and keep on innovating.